Hey guys, here we're going to the topic of Surds. Okay, Surds itself isn't a really big topic, so we'll cover everything in this one video, and it's pretty straightforward once you know the rules of Surds, so it shouldn't be too hard for you all to know, right? First of all, what is a Surd? A Surd is an irrational number involving a square root. Okay, and what we need to know is the different rules of surds. So in this topic, we're going to be dealing a lot with square roots. Okay, so the multiplication rule of surds, okay, is the square root of xy. Let's say we have two numbers xy. Okay, the square root of xy, where both are underneath the bracket, is equal to the square root of x multiplied by the square root of y. Okay, I'll use as a multiply sign. Okay, the dot could be used as a multiplication sign. Okay, good. So basically that's what this says. So example, let's say we have the square root of 8. Okay, I'm going to simplify this. This is the same as writing as the square root of 4 multiplied by 2. Okay, and using the rule from above now, this is the same as the square root of 4 multiplied by the square root of 2, which is the same as 2 root 2. Since the square root of 4 is actually 2. Okay, so let's do another one. Okay, for example, let's say we have the square root of 48 plus the square root of 243 minus the square root of 75. Okay, again, these topics like this, it just takes practice. Okay, now this here is the same as the square root of 16 times 3. 243 is the same as the square root of 81 times 3. And this one here now is the same as the square root of 25 times 3. Again, using the rules from above, this is equal to the square root of 16 multiplied by the square root of 3 plus the square root of 81 multiplied by the square root of 3 minus the square root of 25 multiplied by the square root of 3. Okay, this is equal to 4 root 3 since the square root of 16 is 4 plus 9 root 3 minus 5 root 3. Okay, and again, to simplify this, 9 plus 4 is 13. 13 minus 5 is 8, so it becomes 8 root 3. Okay, so that was it to the multiplication rule. And the second rule we need to know is the division rule. Okay, and what this one simply says is that the square root of x over y is equal to the square root of x all over the square root of y. Okay, so for example, let's say we have the square root of 4 over 9. This would be the same as the square root of 4 all divided by the square root of 9, which is equal to the square root of 9, which is equal to 2 over 3. Okay, another example, let's say we have a square root of 5 over 64. Okay, this would be the same as the square root of 5 all over the square root of 64. Now we cannot simplify the square root of 5, but we could simplify the square root of 64, because the square root of 64 is 8. Okay, and that's basically division rule. It's as simple as that. Okay, now we come to the topic of rationalizing. Okay, and the point of rationalizing a surd is simply that we don't want to have a square root on the denominator because it just doesn't look good. Okay, so what we want to do with rationalizing is to put the square root on the numerator, and it makes it usually easier to work with. Okay, so the best way to teach you this is through examples. Okay, so let's say we have 1 over root 2. Okay, we want to rationalize this surd. Okay, what we do is we multiply by root 2 over root 2. Okay, how to get rid of the square root? If we multiply the square root by itself, it will get rid of the square root. Okay, For example, let's say we want to multiply the square root of x multiplied by the square root of x, we would just get x. And this is what we're really going to do here. Okay? So what this is the same as root 2 over 2. This and this is the same thing. Okay? But this way is just what we say is a nicer way to write it. Okay? So let's do another example. Let's see, we have 169 over the square root of 13. I'm going to rationalize this, okay? What we do is we take the 169 over the square root of 13 and we multiply it by square root of 13 over the square root of 13. Notice that the square root of 13 over the square root of 13 is still 1, okay? So we are not changing anything. Okay, this would be equal to 169 root 13 all over 13, because the square root of 13 multiplied by the square root of 13 is 13. Okay, now 169 is actually 13 squared. Okay, so 169 is actually 13 squared, so we can actually simplify this even further and it becomes 13 root 13. Okay, some calculators, they will actually rationalize, so it's for you to be in a form that we could easier understand. Okay, now in rationalizing, we also have to deal with the conjugate of a surd, right? So sometimes the surd might be a little bit more complex. And let's say we have a surd which is root x plus root y, okay? The conjugate of the surd, okay? If you want to find the conjugate of the surd, it is root x minus root y. Okay, so just adding a minus sign. And let me tell you what's the point of this now, okay? The point of this is that when we multiply a surd by its conjugate, okay? If we multiply a surd by its conjugate, what you'll get is root x multiplied by root x, which is x, plus root xy minus root xy minus y, which is equal to x minus y. Okay, so you don't even have to go through this expansion, because what you'll always get when you multiply a surd by its conjugate is x minus y. Okay, so for example, let's say we have the square root of 3 minus the square root of 2. The conjugate of this surd is square root of 3 plus the square root of 2. Okay, let's say we have 6 plus the square root of 5. Now notice it doesn't both have to be in square root, okay? Once just one alone is in a square root. So the conjugate of 6 plus root 5 is 6 minus root 5. And let's say we have root 3 plus 4. The conjugate of that would be root 3 minus 4. Okay, and it's as simple as that. So now that we know the conjugate of a surd, now we have a little bit more complex rationalizing. So let's say we have a more complex one. Let's say we have 1 over the square root of 2 plus 1. Okay, and we want to rationalize the surd. Right, to rationalize a surd like this, remember before, if it was 1 over root 2, we would multiply by root 2 over root 2. But this one is more complex, right? So what we'll do is we actually multiply by the conjugate. Okay, root 2 plus 1. Okay, we're going to multiply this now by the conjugate in the numerator and the denominator. Okay, so it becomes root 2 minus 1 all over root 2 minus 1. Notice that this term here is 1, so we are not changing anything. Okay, we need to multiply both the numerator and the denominator by the conjugate. So expanding, okay, we end up with root 2 minus 1 all over root 2 plus 1 into root 2 minus 1. Okay, this is root 2 minus 1 all over. Again, remember how the result when you multiply a surd by its conjugate, you would just get 2 minus 1, which is really just equal to root 2 minus 1. Okay, and that was it for this question. Another example now is I'll show you how we have it in a different way now. For example, now let's say we have 5 over the square root of x plus 5. Notice here now that here in the first question, the square root wasn't over the entire thing. In this one, the square root is over the entire of the denominator. So when we rationalize this surd, you know, okay, when you're rationalizing this, what we're actually going to be multiplying by is not the square root of x minus 5, but actually just, I'll use a dot, okay, is the square root of x plus 5 over the square root of x plus 5. Now notice the difference, okay? In this case, the square root is over the entire thing. This is why we multiply by the square root of x plus 5, okay? And this here now will be equal to 5 root x plus 5 all over x plus 5, okay? Now, between me and you, I find this one, the original, is not as complicated as this one, okay? But remember, the point of rationalizing is to remove the square root from the denominator and get it in the numerator, okay? We're trying to get rid of the square root from the denominator, okay? So another example now here, stepping it up, this one's a little bit more harder, is let's say we have x plus 3. Okay, actually, let's say we just have x over the square root of x plus 5 minus 1. Notice that the square root isn't over the entire of the denominator, it's only over 1. In this case, we multiply by the square root of x plus 5 plus 1, because this is actually the conjugate of this, all over the square root of x plus 5 plus 1. Okay, now this is equal to x square root of x plus 5 plus x all over x plus 5 minus 1, which is equal to x root x plus 5 plus x all over x plus 4. Okay, and this is the simplified version. And I'll do one more example of rationalizing. Okay, so let's say now we have x plus 2 over the square root of x minus 1. Okay, if we want to rationalize this, it becomes x plus 2 over the square root of x minus 1 multiplied by the square root of x plus 1 all over the square root of x plus 1. Okay, this here now is equal to x plus 2 square root of x plus 1 all over root x minus 1 multiplied by root x plus 1. Okay, now expanding the top, what we get is x root x. Okay, we get x root x plus 2 root x. Okay, plus x plus 2 all over x minus 1. Okay, so if we to rationalize this, this is what we would get. Okay, we could probably leave it in this, in easier way to write it would have probably just been to not expand the top, so just be root x plus 2 root x plus 1 all over x minus 1. Okay, probably been easier to write like that, but again, it's the same thing. Okay, and that was really it to rationalizing, and that is how you rationalize a quadratic. Okay, sorry, that's how you rationalize a surd. My bad. Okay, and that's really it to rationalizing and the topic of surds. As you could see, it was short and sweet. That's really it to the topic of surds. Okay, so I hope you enjoyed this video, and I hope you learned something from this video. And again, message me if you need any help with any questions. Okay, thanks for watching.